All right, so we would like to have some way of quantifying that variation in the data so that we could look at a number and tell, maybe be able to compare the number and see, like which one has more variation. All right, so that's the goal here, is try to find some sort of quantitative measure for how spread out data is. Okay. Now, you might, if you just think about it, you can think, well, I could calculate how far each data point is from the mean, right? And that would give me a sense of the variation from the mean, the deviation from the mean, right? And then, but then I would like some sort of average of all that, right? I would like to be able to average that. Like, what is the average variation from the mean? Well, so so that's a good thought. That's a good way of approaching it, is to think about coming up with some sort of average deviation from the mean, right? We can calculate the mean easy enough. And of course, a set of data where the deviation, where there's a lot more deviation from the mean, is going to give you a bigger value, which would make sense. So the trouble is with the deviation from the mean, if we just take like the each data point and subtract the mean from it, some of those values are going to be positive, some of them are going to be negative. When we add them all up, some of those they're going to cancel each other out. So we need the positive deviation from the mean. And one way to get a positive deviation from the mean is to square it, because a negative times a negative gives you a positive, right? A positive times a positive is, of course, positive. But if you have a negative deviation from the mean and you square it, you end up with a positive value. So one way to get a positive deviation from the mean is to square it. And then we want an average, okay? And one way we can get an average is to compute the expected value, which is the probability weighted average. So that's what we're going to do here. That's variance. Variance is essentially it's the probability weighted average of the squares of the deviations from the mean. Okay? So I think I said that somewhere here. It's the expected value of the squares of the deviations from the mean. Okay? That's kind of the key here. There's a formula, but it's always good to understand what that means, rather than just plugging numbers in and getting numbers out. So let's take a look at using that. We're going to use that to do example 2. Now this is the same problem. This is the Olivia's potato chip problem. All right, now I've just taken the data for brand A and brand B and then just copied their probability distributions over into example 2. All right, and we're gonna calculate the probability weighted average of the squares of the deviations from the mean. Okay, now there's a lot of number crunching here. There's a lot of number crunching here. So sometimes it helps to keep things organized in a table. And I also want to mention too that some of you may even have calculators that calculate this automatically for you, and you don't even have to think about it. But the goal here is to teach you the math behind that. Now, in reality, I think it's true that you're going to use a calculator, or you're going to use a spreadsheet, or you're going to use some sort of statistical program to do this, especially if you have large data sets. But the goal in this class is to teach you the math behind it. Okay, so you can use, if you have some way of computing these variances and standard deviations, which we're going to get to next, on your calculator or whatever. I want you to show your work. For quizzes and exams, you're going to need to show your work. I don't want you just plugging numbers into a calculator and blindly getting answers. Okay, I want you to know the math behind it. So make sure that you're actually doing the work and not just plugging numbers into your calculator. Okay, because that's not the goal here. The goal here is to teach you the math behind it. All right, let's do this. Now, the first thing we need is the mean, right? The first thing we need is the mean. Now, we really already have the mean, but we could also calculate the expected value. So in general, in these tables, this is kind of the way I set them up. And I will give you the table on a quiz or an exam. Okay, so you really don't have to memorize how to do this. So this column here, it says x times the probability, right? We're going to take each random variable outcome and multiply it by its associated probability, right? So I'm just going to multiply these first two columns, right? So I'm going to take 15.7 times 0 gives me 0. 15.8 times 0.1 gives me 1.58, okay? 15.9 times 0.2 gives me 3.18. 16 times 0.4 gives me 6.40, and so on, right? I'm just multiplying the random variable times this associated probability. 3.22, this one is 1.62, and this one is 0. Okay, the expected value, which is the mean, right? This is expected value. It's also the mean, is the probability weighted average of these outcomes. And so we get 16, which is what we got before when we just did the average. Okay. Next thing I'm going to compute is the deviation from the mean, right? I'm going to take the random variable minus the mean. Okay, so it's always the random variable minus the mean. So you can see this first one is going to be negative because when I take 15.7 and I subtract 16, I get a negative 0.3. Okay, 15.8 minus 16 gives me minus 0.2, minus 0.1. Okay, so I'm just subtracting. So your 16 minus 16 is 0. So this particular outcome is right at the mean. And then I get 0.1, 0.2, 0.3. Now these are all positive because the outcomes are greater than the mean. Okay, so the deviation from the mean is positive. All right, so the next thing I'm going to do is just take those deviations from the mean. That's this fourth column. This is the fourth column. So I'm going to take the fourth column, and I'm going to take it times the probability, which is over here, the second column, right? Second column, right? I'm just taking those values. So this first one will just be this squared and then times its probability. So obviously that's going to be 0. Okay. So then I'm going to take negative 0.2 squared, which would be 0.04, I believe, and then take it times 0.1, which gives me 0.004. Okay. So I'm taking the fourth column numbers times the second column numbers. So I'll just go ahead and do that. 0.02, this one's 0, this one's 0.002, 0.004, and 0 again. And then I'm going to add those up. And what I end up with is 0.012. That is the variance. It's the probability weighted average of the squares of the deviations from the mean. Okay? That's all there is to it. It's just accounting now, right? We're just working with columns of numbers and doing some accounting here. All right, so let's take a look at brand B. Now, again, I'm just going to multiply the first column times the second column. That'll give me this will give me what I need for the expected value. Now, I already know it, but I'm just going to, for completeness, we're just going to go ahead and compute it. So 1.58, 1.59, I get 1.60, 3.22, 3.24, and 1.63. Okay, add those all up and I get 16, just like I got before, right? We're just taking the probability weighted average of the outcomes now. The sum of those are the expected value, which is the same as the mean. All right. So now that I have the mean, I can compute the deviation from the mean. Okay, so I'm just going to take my outcome and subtract the mean. So here I got 0.3, 0.2, minus 0.1, 0, 0.1, 0.2, 0.3. Just subtracting the outcome y, taking the outcome y and subtracting the mean. All right, and then I'm going to again compute the probability weighted average of the squares of the deviations from the mean. So I'm going to square the number I have here in column 4 and multiply it times its associated probability. All right, so when I do that, I get 0.018, 0.004, 0.001, This one's 0, 0 0.002, 0 0.008, 0 0.009. And then when I add these all up, I get the variance, which is 0 0.042. And you can see, remember we had brand B, just visually, we could see in the histogram that it had a greater variance, right? We didn't have it quantified though. Now we have it quantified. We can see that the variance is 0 0.042, which is greater than the variance of brand A, which was 0 0.012. Okay, so now we have some numbers to work with. I want to mention one more thing here, and that is the units of these, the variance. Okay, and this kind of leads us into standard deviation, which, okay, maybe I'll save that for the next video since I'm already over 10 minutes on this video. All right, so I'll see you in the next video to talk about standard deviation.